What's going on, everybody? Mr. Murray here, Mr. Murray's Mathland, and we are doing a video on expanding logarithms today. There's another video in this series of condensing, so I don't know if you've watched this, but expanding is just going in reverse. So I'm going to review these properties that we use to condense, and then we'll just say, hey, we're going to take those properties and use them in reverse. So the addition property of logs, if they have the same base, you can condense them to log base b of a times c, right, by multiplying them, making one argument out of that product. And log base b of a minus log base b of c would be dividing those arguments. A divided by c. The negative log is the quantity, the argument that goes in the denominator, the one you're dividing by. And that power property, anything that's a coefficient, you can make that a power. You can raise that argument to it. Okay, so expanding is really going to be taking something like this and breaking it down into an expression like that. So taking something that's a single log and pulling it apart, taking this kind of thing and breaking it up, taking any exponents you can and bringing them out to the front. So it's kind of like, almost like factoring, I tell kids. You want to try to pull it apart as much as possible, take as much out as you can. So that includes exponents here. So let's see here. Couple simple examples, and then I've got some tougher ones to show you the full range of difficulty, hopefully. We're going to expand each log completely. So first things first, you might say, is how many logs am I going to expand this to? Well, on the inside, I've got x squared y to the fifth. So I'm going to make 2 logs, one for each of those quantities. So this is going to be log base 4 of x squared. And since that's being multiplied by y to the fifth on the inside there, I'm going to make this plus log base 4 of the other quantity, log base 5. Or sorry, log y to the fifth. And now, to finish it off, anything that has exponents, pull them out to the front. So I'm going to take this 2, that 5, and I'm going to make those coefficients. So this is going to be 2 log base 4 of x plus 5 log base 4 of y to the fifth. Sorry, not y to the fifth. I pulled that 5 out. There we go. A mental block with that y to the fifth, I guess. And there we go. So it's literally the same steps, just in reverse for your condensing. Condensing, the first thing we would do is take those coefficients and make them exponents to get to here, and then we would put them together. Well, so we break it up and then pull exponents out. That's really the big deal there. There's a couple other twists on it, but that's the major idea. So number 2 here, log base 8 of x to the fifth divided by y to the eighth. I'm going to break that up to log base 8 of x to the fifth minus log base 8 of y to the eighth. And now I'm going to pull those exponents out in front as coefficients using my power property in reverse. So that will be 5 log base 8 of x minus 8 log base 8 of y. And there we go. Pretty simple. And then that's the basics in a nutshell. But as always, there problems can look a little uglier. There can be more variables, and there can be some little quirks here that might catch you if you're not careful. So let's take a look at this. Now first, we might say, you might say, I'm going to make 2 logs out of this, one for the big division here. But I'm going to go right to breaking it up all the way. And what I'm going to tell you is that for each one of these quantities, it's going to get its own log. I'm dividing by y squared, that's going to get a log. I'm dividing by z to the fifth, that's going to get a log. I got root x on top, that's going to get a log. And 7, that coefficient, that's 7 times root x, that's a product there. 7 is going to get its own log. So I would really break this up into 4 logs. Natural log of 7 plus natural log of root x. And you might already be starting to think ahead to the next step of what you can do to that, and that's fine. And then I'm dividing by those 2 variables, so I'm going to do minus natural log of y squared minus natural log of z to the 5th. Whoops. And now I'm going to pull all those exponents out in front. One thing you might want to watch out for is this right here, root x. It may not be written with an exponent, but that can be thought of as x to the 1/2, right? So I want to pull out everything I can. And that really goes for the 7 also. If 7 were like a perfect square or a perfect cube or could be expressed as a lower base with an exponent, I would want to pull that out. So you do want to look at everything, try to pull out anything you can. So this root x, I can pull out that power of 1/2 and have just 1/2 ln of x, and then minus 2 ln of y minus 5 ln of z. And there we go, completely expanded. Here's another example. How many logs am I going to make? If you want to pause it and try on your own, always a good idea here. How many logs am I going to make? Definitely 1 for the e to the 4th, 1 for the x's, and 1 for the y's here. So just be careful with those x's and the y's in the denominator because they're both under the cube root. So you might like to either take a step and rewrite it or make a mental note to yourself that the cube root of x squared is really x to the 2/3. And the cube root of y is really y to the 1/3. So when I break this up, this is ln of e to the 4th, and then I'm dividing by that, so it's going to be minus the ln of x to the 2/3 minus ln of y to the 1/3. And now those exponents have to come out in front using the power rule. Now you might be noticing something with that ln of e to the 4th, but if you don't, fine. If you go about your business and you say, fine, it's 4 ln of e minus 2/3 ln of x minus 1/3 ln of y, and you might say, all right, I'm done, cool, but ln of e can be simplified. Remember, e is a number, and that is the base of the natural log. So either here, this should have caught your eye, or here, that ln of e is 1, right? So this is like 4 times 1. And so that is just going to be 4. We want everything completely simplified, so that counts. Or if you would back here, a lot of you really, if you're on your game, should have spotted that that's going to be 4, because ln of e to the 4th is like saying the base of e to what power gives you e to the 4th, right? And that's 4. So it's always going to have that inverse relationship where it cancels and leaves you with that exponent. But then everything else is as is, minus 2/3 ln of x minus 1/3 ln of y. So just be honest with yourself. How many of you would have fallen for that? Might not have picked up on that, but not now, right? And the last problem I got for you here, the log of 9x squared divided by 100b to the 7th. So how many logs am I going to make here? I'm going to make 1 for the coefficient of 9, 1 for the x squared, 1 for the 100, and 1 for the b to the 7th. I'm going to make 4 logs here. So this is going to be, everything up top is a positive log. Log of 9 plus log of x squared. Everything in the denominator that I'm dividing by, that's a negative log, right? Minus log of 100 minus log of b to the 7th. Okay. So the variable ones, I think you're probably, if you're at this point in the video, you're probably feeling pretty comfortable with. The constants can catch people sometimes, so just be careful. Log of 9 isn't something I can reduce. And remember, when the base is not specified, that's an implied base of 10. So it's not like log base 10 of 9 is something I know. But 9 is really 3 squared. It can be written with a smaller base, and I can pull that exponent out in front. So I'm going to do that. I'm going to make this 2 log of 3 rather than leaving a 9 in there. And that's considered completely expanding it. It's just like this 2 that I'm pulling out in front of the log of x. And now this log of 100, I mean, you could either think that to yourself that, hey, 100, same deal, is 10 squared, Or you really should be saying, whoa, that's base 10, which this is the same base as the log, meaning this can actually just be evaluated. What is the log of 100? It's 2, right? Because you're saying 10 to what power gives you 100? 2 is that exponent. Or in other words, log of 10 squared cancels, leaving you with the exponent of 2, just like the ln of e to the fourth was 4. And then the last log is minus 7 log of b. And so there we go. We've completely expanded, reduced, simplified, pulled everything out that we can, and that's that. So hopefully you've seen a few different examples and you're feeling pretty comfortable with these properties, condensing and expanding, going forwards and backwards. They really help you when you're trying to solve more complicated equations, or next year in calculus trying to maneuver and manipulate things. It's good to have these skills that you can change how things are expressed. So if you have any questions, as always, ask and keep working hard, kids.